All right, guys, today we're going to be talking about 5-6, which is inequalities in one triangle. This is going to be really easy once we take a look at this. It's just something maybe you've not seen before. So I'm kind of excited about this actually because I know this is going to be something that's going to be something you're going to remember probably for a long time. So let's look at this. It says for any triangle, if two sides are not congruent, that just means they're not the same. Here's the key. Then the larger angle is opposite the longer side, okay? Then it says conversely, if two angles are not congruent, again, the same things it said before, then the longer side is opposite the larger angle. So here's what I want you to think about, and I'm going to try to draw this the best I can, but imagine a door, okay? So we've got a wall here, and then we've got what's called the door jamb, which is this side of the door, and then we've got same door jamb and wall over here, okay? And you have a door, of course, it's hinged right here, and so if you open that door just slightly, okay, there's the door. If you open that door just slightly, you notice that it creates this angle. Okay, so I want to just kind of draw this out. Just bear with me for a minute. You'll kind of see what's happening. So you notice my angle here is kind of small, right here, right? And you also notice that my side here is kind of small. Now, if the same scenario, I still have that same door, but this time instead of opening it really small, I open it very, very large, right, almost all the way open. Then you notice what happens. All of a sudden, my distance here gets bigger, as well as my angle here gets bigger than it was there, okay? So it makes sense that the more you open the door, right, the greater the angle is going to be and the greater the side's going to be. So that's exactly what this little theorem here is really talking about, is that the larger angle is opposite the longer side. So you're going to have a bigger angle across from a bigger side. So let's look at an example here. So it's telling us to use this theorem to try to answer these questions. So it says, what is the largest angle of triangle ABC? Here's triangle ABC. Well, we know that the biggest angle is across from the biggest side, right? So where's my biggest side at? Well, I've got 6, 8, and 9. So 9 units is obviously my biggest side. So this is my biggest side right here. Well, what is the angle that really creates that side? Well, it's the one across from it, right? Just like this side right here, the angle that created that was right straight across from it. Well, the same thing's true here. So that means we can definitively say, just based on these sides that we're given, that angle C has to be the largest angle, okay? And again, we could even rank these from greatest to smallest, which is kind of what it asks you to do in your practice. We'll actually look at one of those examples here in a minute. Well, the same exact thing is true if you're given the angles. You can try to figure out sides. So this is the answer here to the first one, to part A. Let's look at part B. It says, what is the measure of angle E and what is the shortest side of DEF? So now we're looking for a side. We're not looking for an angle. Well, we're not given any sides, but we are given the angles, right? I'm given a 30-degree angle here. I'm given a 90-degree angle here, which means that if I take 180 minus 90, that equals 90. 90 minus 30 would mean that this one has to be 60 degrees, right? So now I'm looking for the shortest side. Well, the shortest side is going to be across from the smallest angle, right? So what is the smallest angle in this triangle? Well, it's right here, right? It's angle D. So what is the shortest side of this triangle? Well, the shortest side has to be across from this angle, remember? So it has to be this side right here, which we would say is side FE, okay? So side FE would be the shortest side of that triangle. So let's look at some examples here. So number 2, it says, what are the largest and smallest angles of each triangle? Well, the largest angle is going to be across from the largest side. The largest side is 7 right here. So that means the largest angle is angle E. And again, we can just kind of use that little mark for angle. You can use the less than symbol on your on Cami, because when you work on the practice, it's going to be hard to put that little symbol in. You don't want to have to write angle every time, so you can just use the less than. It'll be fine. All right, so that is my largest And again, if I'm looking for the smallest angle, it's going to be across from the smallest side. So here's my smallest side, DE, which means my smallest angle is going to be across from that. So angle F is going to be my smallest angle. Okay? All right, so let's look at number 5, which is another good example here. It says, what are the longest and shortest sides of the triangle? So again, I'm just looking at this, and I'm only given 2 angles. Well, I got to figure out what this other angle is, okay? So the first thing I have to do is I know it all has to add up to 180. So if I've got 180 minus 130, that equals 50. 50 minus 15 means that this little angle right here has to be 35 degrees. So now what are the longest and shortest sides? Well, the longest side is going to be across from the biggest angle. Well, here's my biggest angle right here, angle E. So the side across from that is going to be DF. And really just by looking at it, you can tell, right? Sometimes it may be a little bit more difficult to see, but this one we can see pretty easily. So DF is the way I'm going to describe that, is the longest side, okay? So then it says, what about the shortest side of each triangle? Well, this is my smallest angle. And so the side that is across from my smallest angle is right here. So that means FE is going to be my shortest. Pretty doggone simple, right? Shortest angle is going to be across from the, or shortest side is going to be across from the smallest angle. Longest side is going to be across from the longest angle, and vice versa. Now, before we move on to this next part here that we're going to go over, I want to do a little demonstration with you, and I'm just going to use it on this piece of paper here. And I've got 2 straws here that I have cut up. Okay, so this is the first one, and it's both of these straws, I promise you, were the same length when I originally started. Okay, they were both the same length. So what I did is I cut up these straws. Now my mission here is going to be to try to make a triangle out of these straws. So I'm going to start with this yellow one first. So I'll move the blue one out of the way for just a second. I'm going to start with the yellow one, and I don't know, I'll just use that as my base, right? It's the big long part. And again, in order for this to happen, everything's got to touch. No matter how much I try to stretch this straw, it's just not going to happen, right? Because that's got to touch that end, that's got to touch that end. It's just not working. Okay. Now remember, this was the same exact straw. It's just we cut it up a little bit different. So the yellow one is obviously not going to make a triangle. All right. So let's look at the blue one and let's see what happens here. So I have the blue one, again the same length straw when I started. Let's see if we can make this happen. So this is here. This is here. Voila! Look at that. All of a sudden with this one, we can in fact make a triangle. Now I want you just to think about that for just a minute. We took the same straw, just cut it up a little bit differently. Here, I'll put the yellow one back over here again, just so you can kind of see. But yet one makes a triangle and one does not make a triangle. There's got to be something here that's making the difference. So what I want us to do with this particular example, again, this one does not make a triangle, this one does. So let's start looking at the differences. It's got to be how we cut this thing or something, right? So let's take the longest part of this one, and I want to compare it to the 2 smaller lengths. So I'm just going to put them end to end, just like this right here, okay? And I want you to notice something. If I put those end to end, you will notice that even my 2 lengths that I have here together, they do not extend beyond the longest side that I have, okay? So let's look at this one here. Again, this is not magic or voodoo, it's just math. And notice what happens. I have these in the same exact position. I've got my longest one here, then I have my 2 shorter ones, but notice this one extends past this longest side. So whether you realize it or not, these are the same straws, they were just cut differently, and just by cutting them differently, all of a sudden this one did not make a triangle, this one did. So this actually proves out a theorem that we need to take a look at now. So we'll go ahead and move the straws out of the way, and we're going to go back to the back side of this reteaching sheet, which is going to going to help us to really understand and see this. Okay, so here's what this says. It says that for any triangle, the sum of the lengths of any two sides is greater than the length of the third side. Now let's just kind of break that down just a little bit because I think it's going to be helpful. So the sum of the lengths, well that means addition, right? The sum of the lengths of any two sides equals is greater than the length of the third side. So here's what I want you to think about. If you take the two smallest sides of a triangle, it has to be greater than the length of the third side, just like this one right here. I'm going to show you the blue one here again real quick. So here's what we're basically saying. If you add up the two smaller sides and they are greater than the length of the third side or the longest side, then it will make a triangle. Whereas if you take those same lengths, again, your two smaller sides, and it is not greater than the longest side, then it doesn't make a triangle. Now, that still may seem a little bit confusing, but again, it's going to be very simple once we really take a look at this. So here's all you have to do. Look at number 8. It says, can a triangle have side lengths of 2, 3, and 7? So very simply, all you have to do is you take your two smallest lengths that you have, you add them together, and you see if it's greater than the other. So if you notice, I'm going to take 2 plus 3, and I'm asking myself, is that greater than 7? Well, 2 plus 3 is 5. 5 is not greater than 7. It is not greater than 7. So that means these three lengths could not make a triangle. So again, our question is, can a triangle have side lengths of 2, 3, and 7? Well, no, they can't, because there's no way that could make a triangle. Okay? Now for number 9, look at this. Can a triangle have side lengths of 12, 13, and 7? This is a little bit tricky the way they listed this out, okay? But I want you to notice that you're always going to take the two smallest lengths. So the two smallest lengths are 12 and 7, okay? So if I take 12 plus 7, and I'm asking myself, is that greater than 13? I'm going to get, 19? I started at 20. I don't know why. I'm going to get 19, which is in fact greater than 13. So guess what? These three lengths right here, 12, 13, and 7, yes, they could make a triangle. So that's really all you have to do in this particular instance, okay? One last thing that we need to take a look at right here on number 11. It says two sides of a triangle are 5 centimeters and 3 centimeters. What could be the length of the third side? Well, you might think something like, well, it just depends on whether this is my smallest side. This could be the largest side. I'm not really sure what I should do. Well, let's think about this. So if this was my two smallest sides, for example, 3 plus 5, that equals 8, which means that my side length, right, it can't be 8, or we're going to have a problem. Matter of fact, that brings up something else I want you to think about real quick. So what if my side lengths were 6, 6, and 12? Could that make a triangle? Well, think about that for just a minute. Let's use our little straws as an example. If I have one that's length 6 and another one that's length 6, and I have length 12, will those make a triangle? Well, they don't extend past the longest side, but they're equal to the longest side. But think about when you start to try to extend these two up to make a triangle, all of a sudden now I have a gap here, right? So it has to be greater than. So here's what we really need to think about. What we need to think about is that if this was my two smallest sides, in order for it to be greater than, it cannot equal 8, and it can't be 9, or it can't be 10. It's got to be less than that, right? So here is really simply all you have to do for these. And it is really, really simple. So all we have to do is take 5 minus 3, which equals 2. Okay? Then we're going to take 5 plus 3, which equals 8. And so here's what we're saying about this particular, there's a range of different sides that this could be, okay? So what we're saying is this: X would have to be greater than 2, okay? That side length would have to be greater than 2, but that side length also has to be less than 8, okay? So again, this would be our answers right here. Our side length could be greater than 2, but it would have to be less than 8. So let's think about that for just a second. So if we had side lengths of 3 and 5, and now we're saying according to this, it could be greater than 2. So if the other one was 3, for example, 3 plus 3, these are my two smallest sides, equals 6, and 6 is greater than 5. So that works. Let's choose another one. Let's say X is greater than 2 and less than 8. So let's try 5. 3, 5, those are the two side lengths it already give me, and 5. Well, if I take my two smallest, I've still got 3 and 5, which is 8, and 8 is greater than 5. So you see that it still works in both of those cases. However, if I get something that is less than that, for example, this says X is greater than 2. What if I try 1? Well, if I had 3, 5, and 1, and I take my smallest two sides, I've got 1 and 3, which equals 4. 4 is not less than 5, so that does not make a triangle. So you can see how this right here would be our answer. Really simple. Just subtract the two numbers and get that, and it would always be greater than, okay? Then take the two numbers and add them, and that means X has to be less than that particular portion right there, okay? So let's look at what you're going to have on your practice. Basically, you're not going to have to do number 1 or number 2 at all, okay? Number 3 is just like what we've done before. It says list the angles of each triangle in order from smallest to largest. And so again, the smallest angle is going to be across from the smallest side. This, for this example, is the smallest side. So that means angle B is my smallest. Now what would be my next biggest one? Well, it would be the next biggest side, right? Which is here, which means that would be angle A. And then the last, but certainly not least, the longest or the biggest angle would be across from the longest side, which would be angle C, okay? Number 7 is very similar. You're just doing the sides. The one I probably want to look at, because again, we did some examples of this already, and I don't want to make this video like 40 minutes long. So number 11, if you notice here, it says triangle ABC, where AB is 17, AC is 13, and BC is 29. And it wants you to order the angles. Well, I don't know about you, but I am a visual person. I cannot figure that out just by looking at that like that. So what I would do over here on the side, if I were you, is just draw out ABC. You don't have to be an artist, just so long that you can draw out ABC, okay? And then it says AB is 17, so go ahead and label that as 17. AC is 13, so that would go there. And BC is 29. Now it's saying list the angles of each triangle in order from smallest to largest. So the smallest angle is going to be across from the smallest side. This is my smallest side right here, which means that my smallest angle would have to be B. And then you just go ahead and list out the other two angles that would come next, okay? So it gives you an idea of how to do that one as well. And then on the back side, you've got 15 here that again says, can the triangle have side lengths with the given lengths? Again, just take the two smallest lengths, add them together. 7 plus 8 equals 15. 15 is greater than 9, so that means this, in fact, would be yes. Okay. Again, number 19, we'll go through one of these right quick. The lengths of two sides of any triangle are given. Describe the possible lengths for the third side. So there's a number of different lengths that this could be, but here's all you have to do. Take 11 minus 5, which equals 6. So that means X has to be greater than 6. Okay? And then take, so I'm going to put that right up here just so you have it, 11 minus 5, so that you understand what we did. Then we're going to take 11 plus 5, which equals 16. And that means X has to be less than 16. So think about it. X has to be between 6 and 16. Okay? So X is greater than 6, and X is less than 16. Again, I want you to do all these. I know there's some word problems down here. You don't like word problems, but I do want you to do those. So I want you to do all of these except for number 1 and number 2. You don't have to do number 1 and number 2. Some of these I've already done for you, or at least started for you. So you should be able to do this. Just let us know if you have any problems or issues, and me or Miss Willard will be glad to help you with those issues. Thanks.